Now, thus far we have defined a moment about a point. And in reality, this is not realistic, for we can rotate about a point in an infinite number of directions. Realistically, a body is going to rotate about an axis. Now let's consider the following system where F is acting on RAB, and this is going to create a moment of force about point O. What we want to do is project this along another vector, for instance, OB. For us to do this, we're going to have to define a few things. The first thing we're going to have to define is our moment of force about point O due to F, which we found we can resolve via the cross product. Once we determine our moment of force about point O, we now have to project it onto the unit normal that describes line OB. Thus, we can say our moment of force about OB is going to be equal to our moment of force about point O, dotted with our unit vector describing line OB, and this quantity is going to be times our unit vector describing line OB. Now note the term within the parentheses is our dot product, which is going to give us a scalar value. And this scalar value is going to be multiplied through the unit vector describing OB to give us our vector description of said moment. Let us consider an example of this by looking at a modification to example number 1, where we had a force acting on point A. Now we're going to introduce point B, which has coordinates of 10.0, 0, and 4.00 meters. We want to determine the moment of force about point O projected along the line OB. To do this, we're going to recall our moment of force about point O was found to be 0, minus 707, and 707 newton meters. We're going to need to now define our unit vector that describes OB. And then we can project our moment of force onto said unit vector, and then multiply this magnitude through the unit vector. Our unit vector describing line OB is given as 10.0, 0, and 4.00 meters per the square root of the sum of the squares. 10.0 meters squared plus 4.00 meters squared. We find our unit vector to be 0.926, 0, and 0.370. Our moment of force along line OB is going to be given as our moment of force about point O, dotted with our unit vector describing line OB. So we'd have 0, minus 707, and 707, dotted with 0.926, 0, and 0.370. We first have to execute this operation. In doing such, we'd have 0 times 0.926, plus 0 times minus 707, plus 707 times 0.370. This is going to give us a scalar quantity of 262. And now we can multiply this through our unit vector describing line OB. So we'd have 262 times 0.926, 262 times 0, and 262 times 0.370. Thus, our moment about line OB is going to be expressed as 243, 0, and 96.9 newton meters.